So we got a lot to cover today, but here we go. Let's put this up on the board. There we go. All right. So Sebastian, if you want to follow along with the answer key here, I'll put this down. I wish these were a little less. Well, that didn't really help, did it? Okay. All right, so here we have 1, 2, and 3. The answers for 1, 2, and 3 up there. Yeah, thank you. Are there any questions with the first 3 problems here?
I have a question.
Yes, James.
Put the x behind all those equations. Should we like multiply the results by x?
Here?
No, all of them.
All of them?
Yes.
No, so did you watch the video that was posted? So this is the notation, just like I write like things like f of x. I'm not multiplying the function of f by x. So this is just the notation of saying f plus g of x. So I do f of x plus g of x. It's just written in that specific notation.
How do you do C?
For which one? For number 1. So I took f, which is x squared plus 2x, and I multiplied it by g of x, which is 5 minus x. And then I FOILed, so first, x squared times 5 is 5x squared. Outer, x squared times negative x is negative x cubed. Inner, 2x times 5 is plus 10x. And then last, 2x times minus x is minus 2x squared. Then I combined any terms that I had that were similar, so 5x squared minus 2x squared gives me 3x squared. And then I wrote it in standard form, so I had my highest exponent furthest left, and then went down by the exponent number. So negative x cubed, 3x squared plus 10x, and then because I could plug in any number, any real number for x here, and get a real number answer, my domain is all real numbers.
How do you know you can't?
When you have something in a fraction, so if I have an x or a variable in the denominator of a fraction, I can't have it equal a number that makes that denominator 0. So if I have something under an even number square root or even number root, like a square root or a fourth root, those are the 2 main ones that you're going to see are reciprocal functions and square root functions. We probably won't go too much more difficult than that.
I did get 0 for D.
On this one?
Yeah.
So if I have x squared, if x is 0 there, that would be 0 plus 2 times 0 is 0. 0 plus 0 would be
0.
Yep. So you could do.
Do that with all of them then?
Yep. So you could do this 2 ways too. Like I could have done this and then pulled out an x on the bottom, and I would have been like, I would have put x plus 2. So then I could see here if x was 0, 0 times anything is going to be 0. If x is minus 2 plus 2 is 0. Times anything is going to be 0.
How'd you get negative 2 then?
So negative 2 plus 2 is 0.
Oh, you,
So you set the bottom, you set equal to 0, and then solve. And then x cannot equal those solutions. These ones are a little bit trickier because we have 2 fractions, so we had to find a common denominator, and then we had to combine them and solve for this one and this one.
D for 3.
D for 3. This one?
Yeah.
So I have 2 square roots, and so I can't have a square root in the denominator, so I have to multiply by the square root over the square root in order to cancel them out.
Yeah, I see what I did.
Yep, so the square root of 7 times, or the square root of x minus 7 times the square root of x minus 7 is just x minus 7.
Yeah, I flipped the sign because I confused it with when it's not.
I have a question on D for 2.
Okay.
So wouldn't you have to do negative 2 times 5?
Yep, right right here.
So,
So this would be, yep, so it would be negative 10 over 4x to the fourth. And then I can divide both the top and bottom by 2, which gives me negative 5 over 2x to the fourth. Not over negative 2, that's an equals. Equals. There we go. Any other questions here?
2A.
2a. Cool. So I have g of x plus f of x. So I've got 4x to the third over 5 plus minus 2 over x. So I need the denominators to be the same in order to add them. So I have to multiply this fraction by 5 over 5. I have to multiply this fraction by x over x in order to get a denominator of 5x. So that I have 4x to the fourth over 5x plus minus 10 over 5x. And then that would give me 4x to the fourth minus 10 over 5x when I combine them, because I'm adding a negative number here. So I just simplify that as 4x to the fourth minus 10 over 5x.
How do you know when, no, I think you answered that. How do you know when you only have like a simple answer, like the one in C versus the one in 2A?
So with fractions, when I'm multiplying, I just go straight across. Multiplication is kind of the easiest operation when you're working with fractions because you just use what you've got. You are just like negative 2 times 4x cubed, x times 5. So that's the easiest operation versus an add or subtract where you have to have the same thing on the bottom in order to combine them together.
Why can't x equal 0
For 2a, because if I multiply 5 by 0, I get 0, and I can't have 0 in the denominator. That's the only number that x can't equal. And that's why, so here, originally I would have gotten minus 8x to the fourth, or x to the third, sorry, minus 8x to the third over 5x. And you could look at this and you'd be like, oh, x can't be 0. But I can actually factor out an x for both of those, x over x, and then I have negative 8x squared over 5. Then I can cancel those and get my simplified fractions. So when you're working with fractions, it's really important to simplify. That's the only time when you're working with fractions, when you're working with something in a quotient, is the only time you're going to have to simplify for these operational procedures, these mechanics. You need another second with this? Are we good? Another second?
How do you know if it's equal to n greater than or less than n equal to the same?
For these ones?
Yeah.
So for both of these functions, I can go, alright, so x minus 7, I can find the domain of that, and then 2x. So what can I not have under a square root? What are my limitations? It has to be what?
Negative radical.
You can't have a negative number under the radical. So this domain is x is greater than or equal to 7. Because anything less than 7, 6 minus 7 is negative 1. 5 minus 7 is negative 2. 7 minus 7 is 0, which I can have under a radical. I just can't have a negative. And then here, my domain would be anything x is greater than or equal to 0. Because 2 times 0 is 0. I can take the square root of 0. 1 is greater, so then I'd have a positive number. But anything less than 0 here, I wouldn't be able to plug in because it would be an imaginary number. And so when I'm looking at these domains for both of these functions that I'm working with in number 3, I have to take the one that's more restrictive. And what I mean by that is that I have to take the one that includes less numbers that is a summary for both of them. And so when I'm looking at them, 7 is greater than 0. Any number greater than 7 is also greater than 0. So this domain describes them both. So I would choose this domain when I'm working with specifically the addition, subtraction, and multiplication operations, because I can't have a number that's less than 7 in any of these operations, because then this function wouldn't work. It would be imaginary. So I have to choose the more restrictive option that includes both, that describes both functions. Does that make sense? Cool. All right, there's 4 and 5 for us. I'll get it erased. Here, I'll roll up there. That's probably easier to see. And then these ones were composition. So these ones weren't the multiplication. These were g of f of x, h of g of x, f of g of x. So this was like what we learned at the very end of class last time. Good? Okay. Yes. So in 4b, I have h of g of x. So I wrote it as h of g of x, hog x. And I am essentially doing h of 3x plus 1. So I'm plugging 3x plus 1 into my h function. So I have h of x equals, let's do this with different colors. H of x equals x minus 1 over x. So I'm plugging this in for my x's here. So I have 3x plus 1 minus 1 over 3x plus 1. 3x plus 1 minus 1 just simplifies 3x, and I have 3x over 3x plus 1. So that would be the solution, and then it asks for the domain as well. And so I have to solve for when the denominator would be equal to 0. So I said 3x plus 1 equal to 0. Subtract 1 from both sides, so that I have 3x equals minus 1, divide by 3, and x cannot equal negative 1/3. So that's my domain. I love these ones. I think they're so fun. It's like a little puzzle. I mean, it's just like,
I just like go one step too far sometimes.
yeah, that's what happens. You're like so used to having to like simplify it to like the greatest extent, and then it's like, ah. And then you're like, why did I factor something that was unfactorable?
So you distributed the numbers into the x's.
Yep, exactly. So what this tells me to do is I'm taking g of x and I'm sticking it in for the x's within the h function. So this, I read it as h of g of x. So I take the g of x function, and that becomes the x in the h function. So I'm taking this 3x plus 1, and that's what I'm going to plug in for my x values in the h function. So whatever letter comes first, so like here in g of f of x, I'm taking the f of x function, and I'm plugging it in for the x values in the g function. For c, I'm taking the g of x function, and I'm plugging it in for the x values in the f function. So whatever letter comes first is the function I'm using, and whatever letter comes second is the function that I'm plugging in for the x values in the first function. Fun stuff. Fun stuff.
Is this base 6 through 6, 7, and 8? Are those the ones we plug them up here into the equation? It's like one step
Mhm.
more.
Yep, except for we haven't done C and D. We haven't done that yet. That was like the thing we ended with at the end of class. Are there any other questions on 4 and 5? looking at
You do
I's.
it the same as 4, right?
Yep, 5 you do the same as 4. So in this first one, A, you take f of x and you plug it in for the x's in h. In B, you take the g of x function and you plug it in for the x's in h. In C, you take the f of x function and you plug it in to the x in g. Pretty fun. Okay, we can actually just use this for, do you want a second?
Yeah.
So while we're wrapping that up, why don't you grab the second page that you got in class? The bottom of it says decomposing a function on it. So we're going to do example 6, 7, and then decomposing a function. That will end our composition. And then we'll go into inverses.
Is it on the back?
Yep, it's on the back side. So we're going to start with example number 6 on the back side of your second sheet. So decomposing a function is on the very bottom. All right, so I'm going to turn the projector off. I wonder if I'm still rolling with the video. I have no idea. I could be, I could not be. Oh, we're still going. So exciting. Technology. Okay. Let's bring it over here. All right, so if you look at number 6 on the second sheet, we now have f of g and g of f, but instead of x at the end, we have a number. So we've got f of g of 3 and g of f of 5. And so just like with our operations, when we were doing the operations and we had the number at the end, like f plus g of 5, it got easier. So it's a little bit easier when we have a number involved. So for these ones, the main thing is that I'm solving this now, and before I would have written it as f of g of x in the parentheses. Now I'm writing it as f of g of 3. So what do you think I have to solve for first in this function, in this composition? Yeah, so I have to solve for g of x. Great. So the first thing I solve for is g of 3. So g of 3 equals 3 plus 1, which equals 4. So now I have to solve for f of 4, thank you. So now I plug 4 in for x in my f of x function. So I have absolute value of negative 2 times 4. And so that becomes negative 8. And what's the absolute value of negative 8? 8. You put 3 in for the x in the g function. So I do g of 3 first. Yes, exactly, because I'm doing f of g of 3. And g of 3 is equal to 4. So these are the same thing. 4 and g of 3 mean the same thing. That didn't work.
So basically the steps to just decomposing the function is you create the like hybrid function and just plug it in.
Are you on the bottom right now?
I'm on number 6.
No, so we're not quite at decomposing functions yet. Decomposing is like working opposite this.
Okay.
So for this one, we're plugging in a specific number. We're solving for when we have a value of x in the second set of parentheses.
Got it.
So the first thing I have to do is recognize that this means f of g of 3. Then I have to solve for g of 3, which is 4. And then I solve for f of 4, which is 8.
Makes sense.
So f of g of 3 is equal to 8. Cool. So now g of f of 5, I can rewrite this as g of f of minus 5. And so I plug in, so f of minus 5 equals absolute value of minus 2 minus 5, which equals the absolute value of 10, which equals 10. And then I take that value and I do g of 10. And that's 10 plus 1, so that equals 11. So these ones are two-steppers. You recognize what you have to solve for first, and then you plug in what you got for your solution into the first function that's listed in the notation. Any questions on this? All right, why don't you try number 7 with your buddy. So we got a quadratic function and a square root function, so we're taking it up a little bit. So why are Aiden and Ron, you work with Sebastian on number 7? Oh, your sister aren't so long, you guys went first. Nice. Yep, that's perfect. You have a hunter and then what do you do? Yep, so because this means g of f of 5. Which means like, so I have to solve for this value first. I have to solve for the equivalent value. And f of minus 5 is 10. So I plug that into the g function. We're doing number 7, yep.
Oh, yeah. Miss Young, so order of operations, say I have 9 minus 4 under a radical, would I have to subtract them before I do the radical?
That looks great. Nice job.
Square root of 5 plus over here, 5 times root of 5. Yeah, so it would be 5 plus. Yeah, so we list 5 plus 5. 7. You can just plug in the same value.
Make this into a 5 because you know that maybe 5 square root of 5 plus 5 square root of 5. Yeah. Yeah. And then we would be the same as that.
Okay. So did everyone get 5 plus 5 root 5 for A and 4 root 5 for B?
What did you get?
So for A, you should have gotten 5 plus 5 root 5, or you could have written it as 5 root 5 plus 5. Those are interchangeable. And then for, that's not number B, that's A, sorry. And then for B, it's 4 root 5. This is for number 7.
How'd you get 4 root 5 on B?
Divide 80 by 4, you get 20 divided.
Oh, I did it. F of G of X. That's what it was.
Changes it all. That's good.
Why'd you get 4 square root 5?
So I did f of 7, which equals 7 squared plus 5 root, not root 6, 5 times 7 equals 84.
Yeah.
And then I did g of 84, which equals square root of 84 minus 4, which equals square root of 80, which equals 16 times 5. Square root of 16 is 4.
Just because.
So we 8.
We're doing it all. This is awesome. We're like throwing it back to our first day of class.
I have a question. This being
First and second day of class.
Oh, yeah.
Okay. Okay, so last but not least on this sheet, and then we'll move into our last topic of the unit. We're almost done with the unit. I can't believe it. It's kind of awesome. It's taken us.
Are we gonna have homework tonight?
Yes. Are you gonna have homework tonight? It's already posted on Canvas, Bill. Oh, nice try though. At least Dot one has class on Saturday, so
Okay, yeah. So they have like homework like 3 days in a row?
yes. Well, no, 2, but like it's due 8 a.m. on Saturday. But yeah. Okay, so when we're decomposing a function, we're kind of identifying, going from plugging things into each other to now we're like, how can we remove them from each other? And the easiest way, I don't know if I can see this with my video camera, so I'm going to just like, still figuring this out with the board this close. Yeah, I can see that. Okay, cool. So the easiest way to do this is to identify the parent function that's involved, and then what I call accessories, so anything that's outside of the parent function. So right here, I don't have any accessories, I only have something within the parent function. Here, I only have something within the parent function. Here, though, I have stuff outside the parent function. So those are my accessories. So the first step would be to identify what the parent function is. So in number 8, what is my parent function?
Y equals x to the third.
X cubed. Nice. And so what would happen, so it's telling me, it's saying identify two functions f and g such that f of g of x equals h of x. So I'm trying to take two functions where f of g of x gives me h of x. So I'm trying to get to here by plugging one function into another. So the first thing I'm going to do is I'm going to identify the parent function, and this is going to become my f of x. So f of x in this situation is going to be equal to the parent function of x to the third. And then I take this stuff, and this becomes my g of x. Because if I take f of g of x and I plug g of x in for my x value in my f of x function, I get to here, right? I take this stuff, I plug it in for x here, and I get to here. So I'm working backwards. I'm identifying where could I have an x where I could plug things into to get to here. So I identify the parent function, which is my x value, what I'm doing to my x value, and I'm identifying the other things that are involved that I'd have to account for if I was to plug something in only for the x value. Kind of crazy, kind of complicated. This is like, we're not going to spend too much time on this. This is just like next level.
We don't have to solve anything. We just need to figure out what makes.
This is what you're solving for. So you're solving for f of x and g of x such that f of g of x equals our h of x function that we're given. So let's do another example here. So I'm going to put parentheses around this. So what is my parent function here?
Yeah.
What is it?
The radical symbol with the 3 in the little space between with the x inside.
Cube root of x.
Yeah.
So then that's my f of x. I don't have any accessories. I'm just using the parent function. So f of x equals the cube root of x. And then when I plug in x squared plus 1, when I plug g of x into this parent function, I get to here. So f of g of x, or f of g of x, will equal cube root of x squared plus 1. Kind of crazy. All right.
Is that parenthesis on the GX or is that 1?
That's a 1.
That's a sorry. Better. So, I think I made it a parenthesis without writing the 1. I think I skipped a step. All right. So this is where it gets really crazy now, is when we add accessories. So we've got accessories now on 10 and 11. So we don't just have something, and if you don't get that worst use of the word, you can come up with your own thing to describe like extra stuff, additional transformations, like whatever language works for you is fine. I like to make it more simple for myself because mathematical language is complicated.
Are they usually on the right side?
They can be anywhere. Like here, I've got a negative 1/2 and a plus 3. So those are my accessories, essentially. So now, instead of just including the parent function, my f of x function is going to include both the parent function and the accessories. Because remember, g of x is only being plugged in for x values. So if I don't include the extra stuff, in here, then I'm not going to be able to manipulate it. Like I can't like do like an x plus 7 minus 1, like with something in the denominator for g of x and plug it into a reciprocal function and get what I need. So here in number 10, what is my parent function?
1 over x.
1 over x. So I know that this is going to be my g of x value now, because I'm going to be plugging this in for the x value here. And my accessories are this 4 and this negative 1. So I have a 4 vertical stretch, and I've got a negative 1 down. Those are my accessories. You don't have to, I'm just breaking it down further. You can just circle it or a star them or whatever works for you. So for this now, f of x is going to be equal to 4 over x minus 1. And g of x is going to be equal to x plus 7. So that when I plug in x plus 7 in for x in my f of x function, I get back to g of x. All right, why don't you try, you can finish up 10, your notes on 10, and try 11. 11 is even one step further. But it's the same thing. You have a vertical compression here, a down here, and you have a parent function here. So identify your accessories, identify your parent function.
The translation.
There's stuff on the
Yep.
inside.
Looks great.
Go on the bathroom real quick.
Yes, you can.
Do you still not have a recycling?
No, it's in the hallway now.
Oh.
Yep.
Pistol.
Piece of paper?
I'll put some sharpener.
Pencil sharpener, yes, but you're not going to want to use it because it's terrible. But I have a pencil. Here you go.
Is this something like this for the up?
That looks perfect. Yep. Both of those look great.
I have a question. I don't understand. Thank you.
So I'm trying to find something that when I plug something in for x, it's going to give me
And the place where I can plug something into x to give me this would be this x value here. So the reason why f of x is equal to 4 over x minus 1 is because it's more difficult for me to do those add-ons in the g of x function because I'm just plugging that in as specific x. So when I have this function, 4 over x minus 1, then I can plug this x plus 7 for this x value here and write that. No, we you're plugging it into the x value. Remember from our f of g, when we did on this side, we weren't multiplying it by x, we were plugging it in for x. So that became our x value.
Does anyone want to come up and do number 11 on the board? Anyone? Phil, you want to? Yeah? No, you don't want to?
I don't know what's going on with stuff. The 11's kind of confusing. I think I understand it, but
Like, just write it out.
Yeah, just write it out on the board.
I don't have the campus app.
You guys here in the app, like, why didn't mom do it?
I can't school.
You go to Afterlife, but you didn't know this is
Oh, we're doing
No, you don't have to do that. Nice, thank you. Perfect. So Kristen recognized the function, the parent function was an absolute value of x, so that's where I would plug in my g of x function here. That's the point where I'd plug something in. What's inside there is x plus 5, so that's going to become my g of x, and then I plug that in, so that has to be represented with an x here, and then I'm left over with a negative 1/2 and a plus 3. This is like the last step in the race here. If you get operations and you get like the composite functions, but this is like real hairy, it's gonna be okay.
So we don't actually have to write down like the transformations.
You don't, no. I was doing that to be like explicit. No, to be explicit. You're like the homework, I think it asks you, it says, find two functions f and g such that f of g of x equals h of x. So you just only have to write down f of x and g of x. So. All right. Are there any other questions with this moving forward? You guys want to take a 2-minute stretch break? Or you want to go? You look like you're ready to go.
If we don't take the break, can we leave 2 minutes earlier?
Nice try. No. Take a 2-minute stretch break.
Take a break.